Once you learn about functions, there's no way out of them. After learning about functions, everything in mathematics you will learn after that is basically going to be all about functions and how we deal with functions and how we differentiate a function, how we take the limit of a function, how we integrate a function, what is the x-axis cross point of the function, what are the roots of these equations, what are all of the problems that you are going to face will most definitely be connected in some ways to functions. So before we go on to talk about functions, let's go ahead and define what is a function. So a function is a rule that assigns a member of the set A into only one member of the set B. So basically, what that means is that this here is a function. Let's call it f of x. This plot is a rule that assigns a member of the set A, in this case of the set x. This member will be assigned this member of the set y. Those two members can come up together and make a point on the plot. Let's call this point P. P is made up of point x naught and y naught, for example. This is the point x naught and this is the point y naught. So for every member of the set x, there's going to be a member of the set y, but there's a condition. In the definition of the function, it's stated that only one member has to be assigned into the input set. So something like this is not a function. Why? Well, because for the input x1, there's going to be the output y1 and the output y2. So this here is not a function. And how to check for functions? You basically draw a vertical line. If this line hits your curve in two different points, like so, then this here is not a function, And as I have stated before, after you learn about functions, there's no going back, and virtually anything you do about functions is going to be to come up with ways with working with functions. Let's say that this is a function. You plotted your function f of x, and this is the result of your plot. This here is the x-axis, and this one is the y-axis. What you're going to learn about functions, you're going to begin your function journey with learning how to plot functions. So you'll have two sets, for example, x and y, and you'll plug in x into your function and record the y that you get out of the function. So for example, you give 0 and you get back 0. You give 1, you get back 1. You give 2, you get back 5. You give 4, you get back 8. So this here is a function. Why? Well, because for the set x, I got a set back y, and for every distinct value of x, I got only one value out of y, of the set y. We notice in the function I drew before this particular region, in which if I drew a vertical line, I might hit a bunch of points together. So let me redraw this function into such a function to not get confused. So you begin your functions journey by learning how to plot them on a coordinate system. You'll continue by finding out the different important points in a function. And what do I mean by that? Well, in this point, our function has a maximum. It means that in this point, my function has its biggest value. And in this particular point, it has a minimum. This point, we cross the x-axis, and in this point, we cross the y-axis. So in your second journey, you'll learn about important points on the function. You'll also learn about the behavior of functions in important regions. For example, if I were to extend this function and go to the right side up until infinity, what will happen to my function? Will it begin going downward and reach 0 or not? So important regions. We'll continue the journey by learning how to find the area under the curve representing the function. For example, this area here. And we also solve the problem of the tangent line to a point on the curve representing the function. This is a point, and this is a tangent line on that point. You'll learn about detecting change, how your function changes. So it's going downward. After this point, it's going upward. And you will learn about the rate of change of your function. And what if you had multiple functions together? You'll learn about functions, interactions, and you'll also learn about the volume if your function rotates. So what if the function begins rotating around the x-axis? There is going to be a volume created, and we can calculate the volume that's going to be present in that situation. And let's not forget functions manipulation. What if we multiply the function by a constant? What if we change the frequency of a function? Does it have a frequency? Does it have a time period? And so on and so forth. You're going to learn about function types. And this about just summarizes everything that you're going to learn about functions.